Okay. So hello, my name is Anu. I'll be your instructor for today. I'm an instructor for GirlsCodeIt, and today we're gonna go over sets and dictionaries, two data structures that we went over before, but today we're gonna go over in more depth. Now, for agenda for today, we're gonna go over a quick recap. What are sets and dictionaries again? And then we'll go over them in more depth. We'll talk about methods we could use with sets and dictionaries. Then we're gonna do a very cool demo, in my opinion. And we're gonna try and solve 5 questions in under 5 minutes. Let's go. Now, quick recap. So both sets and both lists and sets, they're data types that can store a group of things. Or in other words, they're a type of data structure. And we'll go later, we'll see like what are the main differences between them. Now, also a quick recap for dictionaries. So dictionaries hold a sequence of key value pairs. We could create like an analogy of like an actual dictionary where the key would be the word and the value would be the definition. And going along with that analogy, it wouldn't make sense if there were two of the same words in a dictionary. So yeah, for dictionaries in Python, there are no key duplicates. Now, what are sets? Now, if you've taken some advanced mathematics, you would know, or even just like pre-calc, you would know there's the real number set, there's integers, there's complex numbers, and sets in Python actually represent a real mathematical set, and we can perform operations such as unions and intersections, but that's a little advanced. But the main idea to get out of sets is that sets are both unordered and unsequenced. So we can't index into a set like we can with a list. But we can iterate through a set just as with like a list, with like a for loop. And because it's unordered and unsequenced, there are no duplicates allowed in sets. And if you try to put a duplicate of the same value, Python would automatically get rid of one of the duplicates. So if you see the syntax, there instead of the square brackets, we have the curly brackets to signify a set, but we can also turn a list into a set with the set function. You can see with the variable y. Now set methods. So there's 4 methods we can use with sets. Now, like lists, sets are mutable, so we can in fact add values into the set, unlike tuples. Let's just go over them one by one. So add, what does add do? Now let's just start off with printing our set. So example is a variable that contains references the set over here. We print it, we get what we expected, a set with 4 elements. Now, what if we add a value of 100? Oh, get rid of indented block. Then yeah, the important thing to notice here is that we didn't add 100 to the end of the set. In fact, Python just randomly placed it in as the 4th element. So the add method just adds it to a random spot in the set. And because because sets are unordered. So sets don't keep track of order. Now we can also remove values. So yes, we can remove the 3 over here. Another thing we can do is we can pop out a random value. So if we did pop over here, oh, taking a bit long. Let me get rid of this so you guys can see. Okay, we stop play. Okay, so it popped out the value 1. So pop gets rid of a random element in the set. So that the main differences between remove and pop is that remove, we can specify what value we want to get rid of, and pop just removes a random value. And the last one is clear, and as the name implies, it clears the entire set, returning an empty set. So those are 4 methods we could use. We could add to an element because we can add to a set because a set is mutable. We can pop out a random element, and we can also remove a specified element. In addition to that, we can just clear everything. Oh, yeah, as I said before, we can do union and intersections. We can do unions and intersections. I won't get into it now, but it's just a good thing to know. Okay, yeah, as I said, just to reiterate, sets are not sequence, they're unordered, which means that the elements must be unique, meaning that there are no duplicates. And on the other hand, lists are sequenced and ordered, and that's why we can index into a list, but we can't index into a set. Because lists are, yeah, they're ordered, sets are unordered and unsequenced. I guess we have an example over here. Okay, let's fork it. Let's fork it. Okay. If we run this example, we get what we expected. A list can indeed hold duplicate values, but a set, as we've said, cannot hold duplicate values. So Python automatically gets rid of one of the duplicates. So there's only one 3 that's a string. So yeah, why don't we always use list? Well, if we wanted to have unique values and we didn't care about indexing into a data structure, we could just easily use lists. And Python gets rid of the duplicate elements for us. Now, dictionaries. Okay, fun part, dictionaries. So dictionaries are also unordered like sets, but we can index into a dictionary. And I guess another common thing like between all of them is that lists, sets, and dictionaries, they're all mutable. We can all change them. But like as I've said before, sets, we can't index into them. But dictionaries, we can index into them with their keys, which we'll see later. Yeah, and this is the syntax for creating a dictionary. We got like the curly brackets, and then we just specify the key value pairs. And then like the comma separating those key value pairs. Now, yeah, how can we index into a dictionary? Or how can we access items? There should be an example around here. Okay, yes. Accessing dictionaries. Okay, let me fork it again. Okay. Now there's 2 main ways of accessing a dictionary, and I'll just go over both of them. Let's say example. Dot, yeah, get. Let's say A. I'll print that out. And then let's comment this out. Oh, okay, okay. 1, that's expected. So get is a method where we specify the key, and then we get the value associated with that key. And the value that's associated with the key A is, of course, 1. Now, if we wanted to get a key value pair that does not exist, so you see there's no key, that's a C, it just returns none. So now get isn't what we would call an accessor method. So the basic, it's more of a like a Java concept, but an accessor method just accesses the value within the dictionary, and if it's not there, then like no biggie, it won't throw any errors. Now, this type of syntax, on the other hand, if we tried to say we tried to print out, try to access C, but with this type of syntax, what would happen? Now this would throw an error. And the way I think about this is that here we're just trying to access it. It's an accessor method. And if it's not there, then, you know, just return none because there's like nothing there. But here, kind of like with a list, you know, list, we did 2, 3. And if we tried to access index 4, we did that, then yeah, that will throw an error as well. So with this syntax, the way I think about it is that we're assuming that the index, a value at index 4 exists, and if it doesn't, then Python will just throw an error. So that's one difference between those two ways of accessing methods. But one cool way with this type of syntax is that we can automatically create key value pairs. So if we did this, oh, and then we print example again, then we would see that Python automatically creates a key value pair with the key C and the value 3. So that's one cool thing about that type of syntax. And yeah, those are the two main differences between them. So example.get C would return none if the key value pair doesn't exist, but this would return an error if we just try to access it. But for this type of syntax, we can automatically create key value pairs. Now, yeah, changing, adding values. So this slide just goes over what I've talked about before, how we can, we can create new values that correspond to an existing key name. So if we wanted to do this, oh boy. Oh, that's true because we have this here. We did this, then yeah, we can change the value over here. And we can also add a new key value pair with this type of syntax if we did C over here. So that just goes over what I've talked about before. Now removing values. There's 3 ways we could do this. Let's do another example. 3 ways we can do this. Let's fork it again. Okay, we forked it. Oh, by the way, fork just means just make, like, if you know, like Google Docs, you can make a copy of like any document and it'll then be your own. So you can think about it like that. Now, okay, removing values. For sets, we could pop and it would pop a random value element within a set. For dictionaries, we can specify what we want to pop. So, okay, actually, let me print example here. So right here, that's where we popped A. So A doesn't exist anymore, or the key value pair with A doesn't exist anymore because we popped it. And it also returns the value for the key A, which is 1. Um, for delete, which is kind of like pop, we can delete the key value pair for D, yeah, which after this line, D, the key value pair with the key V doesn't exist anymore. So that's just another way to get rid of a value. And for clear, of course, that just clears everything within the dictionary and returns an empty dictionary. You could memorize the syntax, but the main idea with dictionaries is that they're mutable. One, because we can delete and we can add to dictionaries, and that we can, unlike like lists, we have to index into a dictionary with with keys. Those are the main ideas behind dictionaries. So quite like with lists, we can also iterate through dictionaries. So let's go to our example. Gotta fork it again. Let's fork. Okay. Okay, we got it. Okay. So I think it'd be easier if I did this. Oh boy. Okay. Yeah. Let's do this. Okay. So iterating through dictionaries. It's better if I just take it one step at a time. So what does this mean? Example.items. Okay, so this would just return a list of the key value pairs with tuples. So we can see there's a key value pair here, the key A, and then the value 1. And then Python just create a tuple with then A, then 1. And that would be the first element of the list. And then this the second element would be the second key value pair, which is B and 2. So that's what items is. So it has both the keys and the values. Now, let's go see another example. Okay. Now, we can also just iterate, we could just return the values as well, which are just the values in the key value pairs. And then same thing with keys. We can only look at keys if we wanted to with the syntax. So remember, items, values, keys. Items both, and values and keys, as a name implies, just looks like the values or just the keys. Then next, we're gonna go over like actually iterating over these 3 types. Now let me, okay. So for value, okay, so we went over this before, like with lists. I say I had a list A, and we had, yeah, for a number in our list A, we could do anything with that number or num. So we could just print it. Yeah, 1, 2, 3, 4. So same thing here for value. Or right here, that's just a placeholder. We could put anything. We could put for apple and it wouldn't matter, except that we would have to change this. But let's just go with value. It's much more like readable, and people that are not familiar with what you're trying to do could just easily read the code and like just get it. So for value and example.value. So remember here, values are just the values in the key value pairs. So if we print this out, then yeah, value 1, 2, 3, 4. 1, 2, 3, 4. And I don't know if we went over this, but this is an F string and there's also, we could also format it another way. We could do value 0, and then that format, and then give them value, which, yeah, kind of what we expected it to. So that's just another way we could do that. So yeah, print the values as we expected. So that's iterating over the values of a dictionary. Now we can also do key values. We can iterate both over the keys and values with something called enumerate. So to get both the keys and values, we would have to use items. Because remember, it's a list of tuples, and the tuples are the key value pairs. So if we did examples.items, and if we did index, and then we did, ooh, okay, oh, should I get rid of that? Ooh, let's see if it works. Okay. So this is how we iterate over both the keys and values. So right here, this is the index. Oh, okay, actually, we can print index index and index. Actually, no, string. What am I doing? String. Yeah. So for enumerate, we can unpack the index and also a value for like any iterable. So that includes lists, sets, or like any iterable. So when unpacking, the first value would always be the index, which is like which starts at 0. We can start it at any number. So we start at 10. Yeah, 10, 11. So it just unpacks the index. And this is just another way of like doing a manual index where we would create an index variable, and then within the loop we would like do index plus equals 1. Instead of doing that, we have enumerate to do that for us. So then right here, we're looking at each tuple. And these are, of course, placeholder names. And if you look at it, like if you take A1, for example, A is, of course, the key. And then 1 is the value. So yeah, for each of them, we could print key and value. And that's how we do that. So demo time. Actually, let's go over like the 5 under 5 first, and then I'll just take you guys quickly through the demo. So 5 under 5. So for the 5 under 5, pause it when I ask the question, and then like answer it for yourself, and then unpause it to see the answer. So question 1, which line in this script will cause it to throw an error? So I don't want to give you away the answer, but here, okay. 5, 4, 3, 2, 1. If you haven't paused, pause it and answer it yourself. So throw an error on this line because B is an undefined variable. And yeah, Python would doesn't know the value of B, so that's why it would throw the error. Question 2, what's the output of this code over here? So A equals howdy, a string with howdy, and we're trying to slice it starting from -1 to nx3. So what is the output of this code? I'm gonna give you a second to pause it. Okay. An empty string. Now, why is this? We went over slicing, I think last week, and for slicing, if it isn't a valid slice, then Python will just return an empty string, or just an empty string, or like an empty list. So -1 refers to the last element, to the last character, so Y, and then 3, 0, 1, 2, 3, so that'll be D. And since Python for slicing, the default step value is 1, so we're always trying to go from left to right unless we indicate otherwise. But since we're trying to go from right to left, Python just sees that as an invalid slice and just returns an empty string in this case. Question 3, what's the output of this code over here? Okay, so we have 2 lists and we're trying to add it together. Okay, so what's the output of this code? I'll give you a second to pause it and answer this question for yourself. Okay, answer. It just conjoins both of them together. Now, yeah, Python operators are very flexible and can support many data types. And the addition operator does support adding lists together. Question 4, what is the output of this code over here? So we have over here, A is a list. We have a set, which is signified by the curly braces, and we know it's not a dictionary because there's no key value pairs. And then we basically make a copy here into C, A into C, and then we have trying to do the same thing with B, and then we're trying to figure out if those 2 lists are equal or not. So what's the output of this code? I'll give you a second to answer it yourself. Okay. Answer. These 2 lists are not equal. So as we said before, Python would automatically get rid of duplicates within sets. So this right here, B, actually has 4 elements rather than 5 elements like A. So so then as a result, C would just be like a copy of A. It would have like 1, 2, 3, 4, 4, but D would have 1, 2, 3, 4 because there's no Python does not allow duplicates in sets. If we printed B right after initializing it, you would see that one of the 4s would be removed. Now, question 5, last question. What's the output of this code over here? I'll give you guys a second to answer this as well. Okay. So answer is an error. Well, if you notice, A is a set, which is signified by the curly brackets. And we're trying to index this as if it's a list. But Python throws an error because sets are unordered, so and unsequenced, so we can't index into them as if they're lists. And if you guys have time, we have a challenge problem. So the problem is to give an unordered list of integers and print the values that occur only once in the set. This is probably the solution. So try to do it. I'll just scroll through the solution so you can check later. Let's see. Yeah, so this is the solution. Pretty sure. Let's see. Print the values that occur only once in the set. Oh, wait, no, never mind. I think, let's see, list S3. Oh, wait, I think this is a bit too advanced for you guys. So you could skip over this or like try to solve the problem on your own, whatever suits you. And these are some further readings. If you guys want to learn more in depth about some other data structures, and really in depth how sets and dictionaries work. They have something called a hash. They utilize like a hash function, but that's a bit advanced. We do have a demo, and I guess I'll just go over the demo quickly. So I guess demo time. Okay, demo time. So we went over this, yeah, from like last week's demo, but we'll be improving this with sets and dictionaries. Okay, let me walk you guys through this code. So set your kids config. So when we do input, the syntax word over here, we're asking the user to, input some values. So that's what we're doing right here. We're trying to receive some values from the user. And then don't worry about stripped. Yeah, strip just gets rid of the trailing white space. And because this is a while true loop, it'll never end until we break. And in this case, it'll break only if we put in exit. So then it'll break. And okay, split. Let me run this again. So split, I did screen color equals red. So split, as the name implies, will split the string we'll receive into a list. So if we put ABC equals XYZ, it would split it into this list right over here with this as a divider with this equal sign. So right here, we're going to split it down the middle, and we're going to have two elements in the list config. Now, if the user doesn't follow the proper format of like this equals something else, then there wouldn't be two elements in the array. So then we'll throw an error. And then after that, we're going to check config 0. So that'll be the first element in the array, or this right over here. If this is in config set, so let's look at config set. So we're checking if this first value over here matches this, or this, basically. Then once we do that, we're checking to see, like for the screen color, we're checking to see if the color we choose is one of the color options right here, which is what we're doing right here. And then after that, we would append a list, another list. We would append a list to a list. So basically, config list would be a list with elements that are also lists. So we'll append screen color and then config one, which would be our value red in this case. Then we would print, and if that is not the case, if we did black, which is not a screen color, it would just throw an error and be like, oh, this color isn't an option. And then in other cases, we would just, if it was like screen brightness and we put like 100, it would just append, kind of like how we did here, it would append it to config list. And if this value happens, like if we put like screen darkness, that's not a config within config set. So it would just return, this isn't a valid config option. And at the end, we'd print config list, which is our list of lists, basically. List with elements that are also lists. That's a better way to put it. We did color equals red, and we exited. It would just print. Okay. Now here's a bug within our code. What if we did screen color equals red, but then we changed, oh, you know what? I want my screen color to be purple. And we exited. How can a screen color be both red and purple at the same time? For our computer, computers aren't that flexible, and they want, and it wouldn't make sense to have the screen color be both red and purple. So that's a bug in our code. So how can we fix this? So this is a list. So a list allows for duplicates, right? But we know that dictionaries don't allow duplicate key values. So they don't allow there to be two screen colors, basically. We can change this into an empty dictionary right over here. And because of that, we have to change a ton of other stuff. So let's highlight this. Okay, append. See, append is not a method that we can use with a dictionary. So we have to change that. So how can we add to a dictionary? Oh, we could easily just do this. Screen color equals config one. So the second element. So here we're just either create or change the value of screen color and then make the key value pair. So the value in the key value pair would just be the last element in our config list, or what we get from the user. And we know it's a list because we use split, which like converts it, as we said, into list. See, what else would we have to do? Oh, we just have to do pretty much the same thing over here, but this would be just config 0. So that'd be the this value over here. And okay. And over here, config set. We can also change this into a set because we have no reason to have duplicate like configurations like There's no reason to have two screen brightnesses or like two of the same exact colors. I mean, we can specify like deep red or like light red, but all we would have to do is like maybe do like bright red and then maybe have another one like dark red. Either way, there won't be two of the same like value. So we can just use a set. I'll change this back to red. Okay, let's add that off. Let's see if this works. Oh, okay, so go equals red. But then I change my mind. Was purple. And then I exit. Would you look at that? Okay. It works. It works. Yes. There's no the screen color is just purple and our computer will get that. It's not both red and purple at the same time. It works. So that's how we can implement dictionaries and sets in a real life setting. And that's it for today. That's all I have for you. Yeah. I hope you got something out of this and try to implement really try to implement anything you're learning into some sort of project. And by doing that, you'll understand the concept even more in a deeper level. And if you have time, try to read further into sets and dictionaries. And as I've said, try to implement it into like some sort of project. And yeah, that's all I have for you today. I hope you have a great day and thank you.